With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that determine the concentration of hydroxyl ions in 0.4 molar NH4OH solution having first condition is no ammonium chloride is added. Second condition, when 5.35 gram of ammonium chloride per liter solution is added. So the ionization constant in this case is NH4OH is 1.8 into 10 to power minus 5. So for the first case, we have to tell the concentration of OH minus ions in 0.4 molar NH4OH. This NH4OH is a weak base. It is a weak base. So since it has a weak base, its dissociation constant alpha is less than 1, very much less than 1. So we write the equation NH4OH gives NH4 positive plus OH minus. So this is the dissociation reaction for NH4OH at time t equals to 0. The concentration of NH4OH will be the same. Let us consider this concentration to be A. So this the concentration of NH4OH at time equals to t equals to 0. It's A. And there is no dissociation at T equilibrium. At equilibrium, what will happen? The concentration of ions will be A alpha, and the concentration of NH4OH will remain as A minus A alpha. So this is the condition at equilibrium. And we know alpha here is dissociation constant. Now in this case, equilibrium constant equals to a concentration of products, that is NH4 positive upon OH negative upon concentration of reactant, that is NH4OH. This is our Kb. From the values we can calculate as NH4OH will be A alpha. Concentration of OH minus A alpha. Concentration of NH4OH A minus A alpha. So we can write it as A alpha square upon A 1 minus alpha. So 1A will be cancelled with this A, so we will get as A alpha square upon 1 minus alpha. This will be the value of our Kb. Now, in the first case, what we have to calculate the concentration of hydroxyl ions in the absence of ammonium chloride. So here the concentration of OH minus is A alpha. So we have to calculate this A alpha. And we are given with Kb. Kb equals to 1.8 into 10 to the power minus 5. So 1.8 into 10 to the power minus 5 equals to A alpha square upon 1 minus alpha. Earlier we have said that for weak base, dissociation is very much less. Alpha is very less than 1. So we can neglect this alpha and write it as 1.8 into 10 to the power minus 5 equals A alpha square upon 1. Because the value of dissociation constant is negligible with respect to 1. So, Kb equals to A alpha square, or we can write it as, since we have to calculate the value of alpha, so alpha equals to 1.8 into 10 to the power minus 5 upon A. And here our concentration A given as 0.4 molar. So it will be under root 1.8 into 10 to the power minus 5 upon 0.4 molar. When we calculate this value, we will get as 2.68 into 10 to power minus 3 molar concentration of OH negative. So this was the answer of our part A. So part B says that when 5.35 gram of NH4Cl per liter of solution is added. So since NH4OH is a weak base, when we add this salt, that is NH4Cl, into it, this NH4Cl is strong electrolyte. This NH4 positive is common in both, so due to common ion effect, this strong electrolyte will suppress the concentration of OH negative in this case. So the concentration when we added NH4Cl to NH4OH, the concentration will be less than this. So now we will see. We are given with 5.35 grams of NH4Cl in 1 liter. So we are given with the concentration of NH4OH. In the question it is given, we can see that in the question it is given 0.4 molar. 0.4 molar. And we remember a relation Kb equals to concentration of product, that is NH4 positive, upon OH minus NH4OH. This was the formula for equilibrium constant we have written here. So when we rearrange this formula, as we have to calculate the concentration of OH negative, when we rearrange the formula, we will get OH negative concentration equals to Kb into concentration of NH4OH upon concentration of NH4 positive. So now we have the value of Kb, we have the concentration of NH4OH, that is 0.4 molar. Now we have to calculate the concentration of NH4 positive. So how do we calculate the concentration of NH4 positive? So for NH4Cl salt, when it dissociate, it will NH4 positive plus Cl negative. So we are given that 5.35 grams of NH4Cl in 1 liter of solution. We have to calculate its concentration. So concentration will be molarity equals to number of moles upon volume in liters. So for number of moles we have given mass, that is 5.35, and molar mass of NH4Cl is 53.5 upon 1 liter. So when we calculate it, we will get as 0.1 molar concentration of NH4 positive. So now we have all the values. Simply we put the values in the formula. Kb we are given with 1.8 into 10 to the power minus 5, and concentration of NH4OH is 0.4 molar. Concentration of NH4 positive we have calculated is 0.1 molar. So when we calculate this value, we will get the concentration of OH negative ions is 7.2 into 10 to the power minus 5 molar. So when we compare the two answers, our second value is low. This much OH negative concentration is less than in the absence of that of absence of NH4 Cl. So this proves that when we add NH4Cl, it will suppress the concentration of OH negative and its value will be less. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.